Um, we have a MacBook Pro 15 inches, A1398. It's a no power. This is one of the four machines I think that he brought. Yeah, four machines. Two 15 inches and two MacBook S. One 15 inches done. This is the second one. Yeah, it says no power, but this is really not. I don't find interest in a repair that has gone through, multiple hands and then it comes to you because so much stress, so much. Yeah. Uh, so see, the screws has already been taken out, obviously, because of yeah, only one screw left. Repairs like this are not interesting. It's gone through multiple hands before it gets to you. Uh, okay, so this is a 2013, 2014. Yeah, this is 20. Okay, this is yeah. Uh, hmm, yeah. So obviously, this screw, for example, is not supposed to be here. It's supposed to be a wide screw here. So, uh, hmm. Okay, it says no power. We can confirm that it doesn't seem that it's liquid damaged. So what you want to do is you want to connect our charger to see what's happening. Do we have charger communication? Is Yeah, it starts from there, and then we build up our troubleshooting from there. Okay, it doesn't seem like we have charger communication. Oh, that's because it's not on. Okay, should have charger communication now. Still nothing. Try again. Okay, so how do we confirm? So let's disconnect the battery and then try again. The next thing we want to do is we want to see if we have a voltage on our PPDC in. That will tell us if we have if charger if we're getting any power from the charger onto the board. Let us open up the board view. The board view is 820-820-3662. Let's open up the board view. 20. This is a uh, 820 dash 3662. That's the board number. Okay, so let's then quickly also open up the schematic at the same time. 820 dash 3662. That's our schematic there. Now let us look at how, where is it? This is the board. Let's flip the board to the other side of the CPU. And then this is where the DC in gets plugged onto the board. Let's flip it to the other side here. The DC in gets plugged onto the board from the other side of the board, and then DC in obviously we have 20 volt, and that is going to be that's going to be the voltage that comes from the charger. Now, what we want to do is we want to see if we have voltage coming in from the charger at all. Yes, we know we have we have our charger, but there is no communication. So the first thing we want to do is we want to see if we have PDC in voltage, because that will help us. That will tell us if our charger it's maybe the charger is not connected or there's no power coming from the charger. So J7000 is the point of communication. So the DC jack gets plugged into J7000, and then your charger obviously this is the DC jack. I'm talking about the charging port. That is where it connects to the board, and then the pin 1 and pin 2 of that. Do I need to move the machine closer? Can you see it? So pin 1 and pin 2 of, so what we want to do to make it easier for you guys, let's open up J7000 on the schematic. So J7000 give you guys an idea of okay, so this is J7000. Now we want to understand how So here is J7000. It says MagSafe DC power jack. Now, pin 1 and 2, it's tied together, and that is going to be 20 volt underscore DC in underscore fuse. Then usually when it comes to, okay, in another video we'll talk about how schematics is actually written and how you understand it and what it meant. For example, look at this for example. So it says PP 20 volt. It tells you that this line, it's a 20 volt line, yeah? And it's a DC in line and it's tied to the fuse, yeah? So 20 volt DC in fuse, and then when you move forward, you find the fuse there. Now, but obviously before the fuse, you get a cap, and then here it says no stuff. So what that would mean usually when it says no stuff, it means that cap is not present. You understand? So that's what it's gonna be. That's what it will mean by no stuff. And then we then see that pin 4 and 5 are tied together, which is going to be ground. You see that tied together, and that is ground. And then the pin 6 is going to be adapter sense, basically to sense that adapter is connected and all of that, and all of that is going to then be controlled by U7000, which is going to be which would be a bi-directional line between sys1 wire, and obviously all of that would then eventually lead back to your SMC. Now, first in first, let us see what we have on our PPDC in. So let's flip to the okay. Let's go to our board view. Let's see what we have now PPDC in. So PPDC in, let's click on pin 1. So let's flip the board to the other side because we see most of those signals are on the other side of the board. Let's connect our charger, flip the board to the other side. Let's see, do we have any PPDC in measurements? Okay, unfortunately we have to take the board out. So let's take the board out so that we will get a better idea as to what is happening. So when you get a device that comes directly from the client, it's more interesting to repair because you kind of understand that you are the first person to work on the device. But if it's been to different, you know, it becomes less interesting. In any case, we see we don't have there's no charger communication. The next thing we want to we in our troubleshooting, we have to find a way to build up the troubleshooting process, because that way it becomes easier. First of all, you identify, you see what we just did. First, we have to first identify where are we, what state is the device, is the logic board in. From there, you build up. You know, from there you build it up. Like what we're doing now, for example, we you see we didn't first we're not worried about uh, short for now. That obviously will still come into play. But right now, what we want to do is we want to see if at least we have voltage coming into our board, because we see that we do not have charger communication. And I am very sure, because this is coming from another repair company, that they must have also replaced the DC jack. I mean, in an effort to address the charger not communicating, because there's a hope. I mean, by the way, I don't need to remove the fan, but because the fan has no screw, it's gonna mess when the board is out. It's just gonna mess with the board, so that's why I'm removing the fan. Ordinarily, I wouldn't. There is no need for me to remove the fan. The fan stays on the board, especially because I will need the fan to tell us when we have power into the board. In any case, board is out of the shell. Flip the board to the other side. Uh, okay, the board looks fairly clean, not too bad. Now let's jump right in to make it easier. Let's flip our board to the other side. We don't have time. It's almost time for Salah. I need to go for Salah. So, okay, now charger is connected. Voltage, let's switch our multimeter to voltage mode. Okay, I mean, because we want to measure voltage, you switch our multimeter to voltage mode. And then we have our black probe to ground, and then our red probe will be our directional. Now, another thing is usually you see a black probe to ground and then you use a red probe. However, you can switch them. That's nothing. The only difference you will find is you will have a minus by the value that you get. So if it's 3 volt, you get minus 3 volt. If you're using your left, the black probe, the black. Okay, so Let's start. This is going to be our pin 1 for J7000. This is J7000. This is what I was explaining before. Let's see what you have on our pin 1. Do we have voltage in? Yes, we have voltage in. So which means our, okay, now after that, after we check in that we have voltage in, so pin 1 and pin 2, they are tied together. The next we want to check is what do we have on our adapter sense. Let's check what we have on our adapter sense. We're expecting to have around about 3 volt ish on our adapter sense. Let's see if that is the case. On our adapter sense, that is going to be the last pin. Let's see what we have. And then we have 0. So we're not supposed to have 0. So the next thing we want to do is, let us now go to J7000 and quickly build up while we have 0. J7000 again. um, Okay, so if we see, so adaptive science is going to be it's going to be an offshoot of U7000. Yes. So you say here it says exit. Yeah. So which means in order for us to get exit, we need to have this. So we need to have this. We need to have VCC. We need to, obviously, this needs to be working before it gets exit. So U7000, it's what will send out the adapter sends to your DC jack, and then obviously from there it then detects the presence of detect the presence of the charger being connected. Now directly on our adapter sense, you also have a logic gate here, which is U7000. So the two things we'll be looking at now is going to be U7000 and U701, U7001, and then U7000. So let's quickly check on those and see what's happening and why we do not have. So it's going to be U7000, U7001. Say again, and then U7000. Okay, so search. Now those two are going to be these two here. So let's locate those. Okay, here we can see that is not present. E7001 is not present. So like I said, we don't know why it was taken out, and then for all we know, that might not, that might just be like a distraction. I mean, we're not sure why it was taken out. So now we have to adjust that, and then maybe now face our real problem. We don't know. And so we can clearly see the reason why we don't have communication on our charger is because U7100 is not present on the board, which is our U7100. That is going to be our logic gate. So basically, that's going to send out. So we have on our logic gate, basically, it's just a simple. Pin 1 and 2 is going to be SMCBC AC. Okay. Pin 5 of it is going to be your PP342. That's where it's going to get power, and then the output of that is going to be Y. So this is now, if 1 and 2 and 3 is present, then you get Y. You understand? But if this is not present, definitely you will not get Y, because the conditions are not met. So this is not present, which is why we obviously do not have at that percent. So what we want to do now is we want to install that. I kind of feel like this is just like a distraction. I mean, that can be the problem. I mean, because no, but why was it taken out? Because I mean, I don't suppose somebody. I don't know. I don't know. But I just feel this. I just feel like that is a distraction to the main problem of the machine. That's the thing with when the job has been to multiple hands. Okay, let's get a board to install that. Yeah, when you're less busy, you can also do that. Okay, so let's install our E7001. I don't know. I'm just so convinced that this is like a distraction to the main problem. I feel like we will have this sorted out, and then we see what the main problem is. In the videos that you showed yesterday, there's also one of the segment of the video was also other way. Was it this way? Yeah. No, you had we had multiple shots in that section of yes. Sure. You know how long that video was? That was long. Okay, so U7001, it's installed now. Now let's see what we have after it's been installed. Like I said, okay, yeah, let's see. Let's see what happens now after it's been installed. Do we have charger communication? Okay, we don't have charger communication. So, but now let's see what do we have. What do we have on our adapter sense? Do we still have PPDC in voltage? PPDC in, do we have it? Pin 1, yes we do. Adapter sense, what do we have? Now we have 3.3 volt. Okay, fine. We have 3.3 volt. So at this point, we want to quickly just, now that we have 3.3 volt, we just want to quickly, uh, now we can check with another, okay, just going to do this. So initially we were having 0 volt. Now we have 3.3 volt, but still we do not have, okay, let's, let's check that again. Okay, now let's see what we want to see. What we really, don't tell me that this was also, no, no, why was that taken out? I hope this is not going to be a joke. uh I don't understand why take out components from the board and just leave it empty. uh okay, okay, so that is sorted out. We now have to, okay, so nah, I don't like this. Okay, let's let's quickly put that.
Maybe a client took the ball to the show
Hmm.
to a different technician,
Yeah,
and
definitely.
they couldn't
Fix the problem.
fix the issue, or maybe they overcharged the client and
Yeah, but then
they
why
had
take out?
to take out things so that it doesn't work to give it back to the client.
Yeah, but it's not gonna. It doesn't make sense. It doesn't make sense. It doesn't make sense. That's why, okay, the SMC will play a major role in having to have our charger indicate charger communication. So what we want to do now is we want to find out if our SMC is running. How do we do that? We see what we measure in our PP pulse voltage. So let's quickly uh, let's see what we measure in our PP pulse voltage to confirm if our SMC is running. PPDC in, we already confirmed. We have, okay, yeah, let me just show you what that is gonna. Let's show you guys. Well, let's flip to the other side of the board. Now I'm gonna measure on these two resistors here. So one is gonna be a PPDC in, which is, we know we have 20 volt, but the other one is gonna be our PP pulse voltage. So and that, and then it will obviously go through this dual 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 intake and then single phase out diode. So which is, I'm talking about 1 2, and then that's a diode. So first I want to see, obviously this is present, we confirm that it's present, and then the other side we wait, what was that? Why 14? Okay, we have 16 and then we have 14. Okay, fine, but first let's, that's not fine because that's 14, that's lower than what we have at the beginning, so that might have to go. But let's see what we have on our PP bus. PP bus is 12.3 and not 12.6. So PP bus being 12.3 tells us that the SMC is not running. Let's just see what we have on our PP342. We have 3.3. Yeah, 12.3, it's an indication that the SMC is not running. So it should be 12.6. So what you want to do is we want to head over to the section of our SMC, give it a slight reflow, see if we have any reason. Okay, just that in order to allow us to remove the edge bonding. Okay, there's something I'm saying at the SMC. There is a cap that looks to have liquid on one section on one side of it. We will shortly see what that cap is and also check if that cap, okay, yeah, that cap there, that doesn't look good. When you're removing the edge bonding, you be very careful not to knock off component with your tweezer. Right. Okay, the edge bonding is out. So let's see what is really is a knockoff component here also. These people, that's spider. Uh, yeah, these people are gonna just make. Okay, so the SMC, we have that cap there. That's gonna be on. So one, yeah. So most likely because of that cap is not looking good. We have corrosion on that cap. Let's just take that cap off. That could be creating a short on that line, which is the 1.2 volt SMC VDDC. So that is out. Let's see with that cap out of the line. Let's see if we have any changes. We have 12.6 or still 12.3. And also that also shows us that there might be a bit of a liquid in that section of the board. It might be yeah. So okay, now we have charger communication. So definitely that cap C5012 was having was shorting PP was shorting PP 1.2 volt of the SMC to ground. Now let us see what we have on our PP box underscore G3 hot. What do we have? Do we have 12.6 or 12? Yes, now we have 12.6. So now definitely the SMC is starting. Now the next thing we want to do is we want to see if we have fan spin. See if we have a fan spin.
So 12.3, it's a sign that
The SMC is not running.
communication.
Yeah, that's on the MacBook Pro. And if it's a MacBook Air 8, it's going to be 8.2 instead of 8.6. 8.2, 8.3 tells you SMC is not running. So not, yeah, yeah. So that is a very good indication of SMC. So we could have another thing we could have done is do a build up here. We will be able to also find out that our issue is coming from the SMC from here, because obviously by checking this section here, we will be able to find a missing signal which is coming from the SMC. Yeah. Or we will obviously find a behavior that suggests that the SMC is not doing what it's supposed to do, which is why we do not have communication on the charger. But then another quick way to do that is just by to just check what you have on your PV bus and see if you have 12.6 or 12.3. So if we had 12.3 or if we had 12.6, we would obviously concentrate our troubleshooting still here. So let's see. Okay, so we have power, but I'm not. I'm very skeptical with this board because yes, we have power, but I don't know if we will have. Um, if the device is going to pose. Like I don't understand what. See here, I don't know what were they doing here. Like I don't know. I don't know. I don't know. Yeah. So now the device is firing on, but I don't know what they had to do here. Why they had to come there. Uh, okay. Let's see if we have if the device is posting. Yeah. This is so if this was coming from the client directly, seriously, I will have more joy to work on it. But now you have to worry about why that was tempered, and then because you kind of look at it as okay, like why? Now, as far as from what we can tell, it's the original issue of this machine was the short on the SMC line. I mean, yeah, that was the original because I mean that was uh, but yeah. So okay, let's just put a speaker, connect a speaker. Hope that we'll get a chime sound which indicates that the device is posting. When I tell you, yeah, even though the device powers on, don't have much confidence on the device because I don't know what I've been messed up. It actually chimes. That is I don't know. Yeah, I mean that's a relief because yeah, it does chime. That's a relief, and then we have also we have. So you guys can see. I don't know if you guys can see that. That's wait like that. Can you see it now? Still no. You can see the upper glow at the back. We have to wait for the question mark folder. Okay, there you have it, guys. Uh, yeah. So, but still, the device of yesterday will be tested, and then we just hope that we don't have to come back to the board for yeah, because it's just like it's like a rabbit hole. You don't know what was messed up, and then you have to keep looking and looking and looking. In any way, the device it's ready. It will go through. It will get assembled, go through the standard testings, and then we'll see if we have a reason to go back to it. But for now, the device was not coming on. As far as we can tell, the main problem was. Let's go back to this. The main problem was C51. C5012 was basically damaged. It had liquid on the section of the cap, and the insulation material between obviously the cap is no longer doing what it's supposed to do, and then it became a wire, and it was shorting the 1.2 volt S5 SMC to ground, and that was why there was no communication on the charger. Why the logic gate was taken out, we don't know. Why the other resistor was taken out, we don't know. But yeah, the and then we were very skeptical as to hoping it probably will have multiple other issues because of the random components that we see were taken off the board. But that is not the case. This is one of a kind. So the machine actually starts, and we actually have Apple logo. And yeah, so the next thing we want to do is the device will get put together, and then tested, and then we hope that we won't have a reason to come back to the board. Okay, thank you guys. I'll see you guys in the next video.